What were your first mathematical memories?
It's not clear what mathematical means, but I think I knew about negative number by looking at the thermometer. And then my brother explained to me how to write the product of two negative numbers was a positive number.
So your brother was how much older than you were?
He was 7 years older than I was. So he could teach me when I was in primary school. He could tell me things about he was learning in high school, like second-degree equation. And that was a miraculous construction to get this formula for the solution. And later, when he was at the university, then I could also look at the course he was having, and then I saw the solution of third-degree and fourth-degree equation with terrible proofs, just making strange algebraic manipulation and finding some formula. But it was all very intriguing things he was telling me.
So you still found it interesting even if the manipulation was unmotivated?
Yes, the fact that there was this kind of solution was interesting. Of course, I tried to compute to see what it was meaning without succeeding, but then it was the challenge of understanding what those manipulations were for, which I could not solve. I learned only later that one has to use symmetric groups to understand what is happening.
Well, how old were you when you first learned about negative numbers and quadratic equations?
I think negative number before I learned to read, I think, so maybe 5, 6. Quadratic equation maybe when I was 8, 9.
And so already then you understood that this was something that was very interesting to you, at least.
Yes. I have some vivid memories that's much older when I first was told about holomorphic functions and the fact that story for a complex variable was so different from the story for a real variable. I find it mind-boggling.
You heard about this from your brother as well, or from your teachers?
I don't remember, not from my teacher, but there was a friend of the family who was a meteorologist, and so I was already 15 or 16 at that time, so he gave me some elementary number of one complex variable, where I learned those amazing facts. Or I remember also reading that the complex numbers were algebraically closed, and I was very puzzled that you add the square root of -1, and then you would get solution for any equation. So I asked, but what is the square root of I? And then the teacher told me the answer, and then I began to understand what it was meaning. I checked 1 plus I divided by square root of 2 squaring, and indeed you were getting I.
When did your teachers first understand that you were exceptional in mathematics?
Oh, my teacher in high school, I think already when I was 14, and the director of my high school was a mathematician, so he would sometimes tell me things about that theory. He had some interest in that. But it's not from my high school that I got some real help, but from Mr. Ness, who was also a high school teacher, but not in my high school, and which I knew through the Boy Scout, because his son was older than I am, 4 years older about, and when I entered the Boy Scout, it was about the first person I met. And he became a friend, And then he introduced me to his father, and then I told a little about with the father, and he thought I was really interested in math, and he gave me Bourbaki set theory. It was a very not obvious decision on his part, but it turned out very well for me.
Did he realize it was a not obvious decision?
Yes, I think he was wondering, but maybe I was asking basic question, and I don't know how he dared to do it, but he did.
And how did it work out for you? Many people would think this would be too formal for someone at that age.
I found it was very helpful to... One attraction of mathematics is what you do is true, that you don't have any doubts. But for that it's useful, I think, to also know this formal basis of axiomatic system, and to understand what a proof really is. And it does not mean one has to be rigorous all the time. On the other hand, if one has a clear idea of the difference between what is a proof and what is not, it gives more liberty not to be rigorous. So it took me, I think, a year to read this book, but I think it has been very useful for me, even if it sidetracked me somewhat. I got somewhat interested in what the treatment of that theory were, like what the intuitionism would tell, Brouwer work. And with that I essentially never did anything except up to this day, when I can make an argument not using contradiction, not an argument by contradiction, or less important, not using the axiom of choice, I prefer to do so.
See, so you feel an argument is better if it does not use the axiom of choice.
Yes, but I also realize now that it's not usually the axiom of choice which makes things not effective, but it's arguing by contradiction. And I think it's often by laziness that one turns an argument this negative framed, and avoiding the axiom of choice is just a hassle, but turning an argument by contradiction into a more constructive argument usually is instructive, I find. So this is what I am left with from this brush with intuitionism.
When did you first meet Jacques Tits?
I think I must have been 16 about, and it must have been thanks to Monsieur Ness, but I don't remember exactly.
So Monsieur Ness was
this high school teacher who gave me my first Bourbaki. Yes, I think that I had made some kind of mathematical notes about things I was thinking, and he may have shown them to Tits. I don't know how he knew Tits. And I would expect Tits was receptive in the sense that Tits very early went to the university. And so seeing someone like me who very early was interested in mathematics, it must have been convenient to him in some sense. And then he said that I could attend the course he was giving at the university, which fortunately was on Wednesday afternoon when there was no school. And that first course was on Lie groups, but very elementary. But it is at that course that I had my first understanding of transport of structure was meaning. Yes, Tits was very geometric, so very interested in symmetries, and so transport of structure was something natural for him. And I remember the occasion, he was, I think, wanting to define what a nilpotent group was, so start by defining the center and then telling one wants to divide by the center. And for this, the center has to be an invariant subgroup. So he started giving a proof, and then he stopped and said, invariant subgroup means that it's invariant by inner automorphism. As I have defined the center, it is invariant by any automorphism. And this was really a revelation for me, how a statement which was not looking obvious at first was made completely transparent by an argument of transport of structure.
Did he use the word transport of structure?
No. Those words I learned only in the third chapter of Theorie des Ensembles, which now exists only in a revised and diminished edition. There it was very well explained what constraint you have to put on what you are willing to say in order that you can use transport of structure without thinking. So this is also a reason for me to always be very careful of the definition, because depending on how definitions are formulated, control the way transport of structure can be used.
I see. So you somehow understood that care with definitions was important before you had ever met Grothendieck.
Yes.
Mr. Nace must have been an incredible high school teacher to know about the Bourbaki and to know Tits.
It was at the time when there was the new math fashion, and he was taken by it, but I think in a very good way. So he had organized some mathematical circle at. He was Flemish, so it was at some Flemish school, and then they were so he asked me, I remember, to tell a little about categories and the fact that there is some symmetry between the property of injection and surjection, which can be viewed in the point of view of categories, even if there was not a self-dual category, the category of sets. That was not the usual fare for this little circle. But
so this was a circle like the Russian circles of good high school students getting together?
Yes, but I don't think there was not involvement like in Russia from people at the university, but it was this very enthusiastic high school teacher who felt that some of his students would gain from being exposed to some somewhat more real mathematics than the high school fair. The high school fair was not so good. At that time, we still had geometry. So we held real proofs, and proof when we were proving things which were not obvious, and so one was seeing the need of a proof.
So then you were 14 when you started to take seminars at the university.
No, 16. I started reading Bourbaki at 14.
Sorry, you were 16 when you...
At 16, yes, and then there is a story which perhaps is apocryphal, but Mr. Nace told it to me and I like it. So it seems one day Tits was to give his lecture and I was not there. So he inquired about the students, what happened to Deligne, and the other students say he is in a school trip. And then he decided to postpone for 1 week his lecture course.
I see. So Tits already understood that something interesting was happening. I see. So did you take other seminars at the university?
Yes, I was, in addition to Tits, there were Bingen and Walbrook who were active, entered the Seminaire with the subject changing from year to year. 1 year it was some basic algebraic geometry, but not in the language of scheme, but only more in the language of Serre, the language Serre used in Faisceau algebraic coherent. So of an algebraic closed field, notion of algebraic set in projective space defined by Quiff. And I think that was Tits who wanted to know more algebraic geometry, and that's why that was the subject of the seminar that year. And another year it was on C-star algebra, which was more the specialty of Walbrook. So things like the square root lemma and basic things about. And also, yes, Walbrook was very interested in if you have an analytic function on the spectrum of an element in a C-star algebra, you can apply the function to this element. So this kind of functional calculus.
How did you come to go to Paris? When was it, and how did it come about?
So it was, I think, the idea of Tits, presumably together with, he spoke with Bingen and Walbrook, and they thought it would be good for me to go to Paris, and so the first time it was just in the fall, I think, when I was 20. He said it would be good if I attend Bourbaki's seminar and he would introduce me to Grothendieck. So it was very strange to see Grothendieck for the first time. I had nothing essentially to tell to him, so it was very brief, but he was kind, but nothing to be said at that time. And as this was kind of successful, then I continue in the spring. I could go to Paris. I was in Cité Universitaire, Boulevard Jourdan, and essentially I was attending Grothendieck Seminaire and Serre in Collège de France.
So Grothendieck seminar was at
in Bure,
at the
yes.
Bois Barry already,
Yes.
in the same.
Yes, in the library at that time. It was hard, so it was only attended 2 hours of lecture a week, and it took me all the rest of the week to try to understand what those people were doing. And the style were completely different, of course, for Grothendieck and for Serre. And then the next year I spent most of the year, maybe I was 21 already when I went there, because afterward I had a gap with my military service. People were very tolerant of me being completely ignorant, maybe seeing that I was willing and able to learn. So I remember one of the first lectures Grothendieck was giving. I did not understand much, but more for a reason of vocabulary. He was using all the time the expression cohomology object. He was playing with complex of sheaves and such things, and I did not understand what object there was meaning. So after the lecture I came to him and asked him, what do you mean by cohomology object? And I think that's a sign of how he was, that he did not consider I was stupid, but just told me if you have in an abelian category A mapping to B mapping to C and the composite is 0, and the homology object for this sequence is this. That's the obvious definition. Then I understood what he had been telling, because I knew that for abelian groups, but I didn't just know the terminology. So I was a little less ignorant than it seemed, but still this reaction of just be willing to quietly explain something which should have been obvious for everyone, I think was kind of typical of Grothendieck.
I've heard people say that he was always very kind to students when they didn't understand, but if someone was older and had pretensions, he could be less.
That's quite possible. And I think he was completely willing to explain something once. I don't think he would have been willing to explain it 3 times, even to students.
So this must have been a non-obvious decision when you arrive in Paris the first time to go to the courses of Grothendieck and Serre. In retrospect, it's inspired, but...
I think it was the advice of Tits, who understood what would be good to me. I think he had seen he had somewhat abstract turn of mind with some interest in categories, general construction. So that was making Grothendieck a natural possibility. And Serre, maybe he thought that I was needing something else, something of a different nature also, to keep me with my feet on the ground.
At this time, what was your formal status? Were you involved in a degree program?
I was a student at the University of Brussels, so the 4-year course of study to get some first diploma as mathematician. And people in Brussels were very good, and the system was very flexible. So essentially it was all right that I'll not be there during the year as I was in Paris, and I came back for the examinations.
Was it directly after you graduated that you went into the military service?
Yes, and that was really a lost year. There was nothing to do in the military, but in some administrative thing or making some errand for the adjutant. So there would have been plenty of time to do mathematics, but I find it impossible to do mathematics if I don't have enough sleep. And with being able to start sleeping at 10 and being waken up at 5 in the morning, impossible to do mathematics afterward. I tried. I had with me the resolution of singularity of Hironaka, and then at times I was going under a tree and trying to read it, but I did not really succeed in...
It's not the easiest thing for those circumstances.
No, but that was something kind of obvious. Grothendieck was using it a lot in his way of doing things.
Where were you doing your military service?
Belgium was occupying Germany at that time, so it was near Bonn that we were.
Did you have any interaction with the mathematicians in Bonn?
I went to the Arbeitsteilung in Bonn, so it was not completely obvious, but usually people were going as often as they could to see their family every week or 2 weeks, and I had kept my possibility to leave the place to have a block of time for the Arbeitsteilung in Bonn. And so I think I must have gone there with my military uniform at the Arbeitsteilung.
This would have been which year approximately?
66, I think.
So the Arbeitsteilung was already an established event.
I don't remember anything from this Arbeitsteilung except how it was organized. I don't think I understood much from the talks, but I don't remember.
So was there any benefit at all from this year?
No, I would say it was a lost year, and I had wondering for a long time whether I should just not do it, but then I could not have gone back to Belgium for a long time. And so I decided to do it, and I decided to do it as short as possible, meaning not being an officer, which was taking 15 months, but plain soldier, so that was 12 months only, and to get rid of it as soon as possible.
So then when that was finished, you came back to Paris.
Yes. I think almost immediately I was paid by IHES. And I think that was Grothendieck doing, that he thought it was good that I would be there. And then later it was his doing also that I became a permanent member at IHES. Tom was much more skeptical, as I was told later. The end of this seminar, Grothendieck asked me to write up talks of the previous year, that the previous year was SGA4, the talks on direct image with compact support and on Poincaré duality. And so I started thinking and writing some notes somewhat during that time, but I did not go very far.
These were talks you had given?
No, he had given the previous year, so I had not attended it. But the seminar I had attended started by recapitulating the previous seminar, which was on those basic things of étale cohomology. And he had a whole group of people around him writing things up for him, but he had not found a victim for those particular talks, so he asked me, and this was one of the best things which happened to me, because writing this up, so at that time during the military service I did a little bit and showed it to Grothendieck, which told me it was much too short, not enough detail, and also practical things like I should never write on both sides of a piece of paper. I should always leave enough space between two lines so that he could write comments in addition. So so useful things in every possible way, he told me, and then I did it again, and in this way, that's really the way I learned L-adic cohomology. And he was very generous. I could ask questions, there were some notes, and also he was very happy that, and me also, that I did not just try to follow his note and make a nice text with it, but I tried to do things a little differently. This happens in some appendix for the talk 17, that cohomology with direct image with compact support were defined for map which could be factorized by a proper map. And so I try to understand how to do it in general by localizing the construction. And also I did it somewhat differently for Poincaré duality, where in Grothendieck talk it was for maps which could be factorized through a smooth map. And essentially I thought that one could do things backwards, taking the theorem as definition in the way Verdier was doing to define F upper freak, and then what was the definition became the theorem that for a smooth map it's something easy to describe, this upper freak, which gives rise to Poincaré duality. So he was very happy. I was playing with this and adding things.
Grothendieck liked it when you changed his ideas around.
Yes. And he was very generous. Basically, it was adding a few things and having fun on some sad aspect of it, but I think he insisted at that time that I be listed as author of the talk instead of just written instead of, what the phrase, instead of rédigé by, I was listed as author of the talk, which was really not reasonable.
I had the impression that everybody wrote up the talks that they gave. I guess this did not.
No, that was often it was talk Grothendieck gave, and somebody else was writing those talks. It for the very active participant like Artin, I think Artin indeed wrote the talk he gave, but for many things, so I was not there at SVA4, but I expect many things were explained by Grothendieck and written up afterward by other people.
You had Grothendieck's recapitulation of what he had said the year before. Did you also have people's notes about it? Or?
I had Grothendieck's notes.
Grothendieck's, I see.
So I became very good of deciphering his handwriting, and still now I can read easily his handwriting.
So tell me a little about this seminar. I mean, it's one of the big mythical things in mathematics.
So basically for me it was Grothendieck explaining things, and the best people, students of École Normale and Dieudonné, Chevalet, coming to listen. And I have some reminiscence. Maybe I have changed it, memory might be a little unfaithful, but I think it was really his style. And maybe it was the previous year. So he started by telling that he wanted to explain change of basis for a proper map. And then it was one obvious thing after the other. Some dévissage, you factor the map through, first you used for lemma, then you can factor the map through successive things of dimension 1, then you reduce to the constant phi in such and such a way, and everything was easy, and at the end you had a theorem which was very surprising. And at his best, that was his style, and that was what he was aiming for. Something in the other, contrary direction, which I remember from much later, when he was already away from mathematics, but was getting some things from Buhr. He got some blurb about me that he had done some very difficult proof, a tour de force, and for him that was really a put-off. It was meaning things were not understood. And I was agreeing with him, but I did not care about what was in this blurb. Something is understood when the proof becomes trivial, even if it is at the cost of having 100 pages of definition of general construction going before. So he was extremely careful of how things had to be approached, what were got a good definition, and also what the good terminology should be. So for instance, I remember about mixed-Hodge theory, those mixed-Hodge structures I had first called them impure, by opposition to pure, which was fixed value for P plus Q, and he did not like that at all. So
he didn't like the word.
He did not like the word. So I think he would have been. Yes, and later he told me it was a terrible idea to speak of perverse thieves for such a beautiful notion. So he introduced those very good terminology of smooth map, étale map. In that time he was still using unramified, but then preferred to say net for this notion of unramified map. And in those basic notions, one has a great care about the definition. They are very elegant definition and of way of checking them, like for smooth map, the criterion by infinitesimal lifting.
So I think of this as Grothendieck's style, the idea that you make beautiful natural definitions and then everything should follow. Of course, that was in place by the time you arrived, but do you think he had to struggle to get this style, or it was just part of his personality?
I think even if before, when he was interested in topological vector space, this notion of looking at properties of topological vector space in terms of properties of the tensor product, that was already this style. Like later, flat module is defined by properties of the tensor product of this module with a variable one. Of course, many things introduced and which for us now are part of breathing had been introduced already, like the fact that one put things at schemes in terms of the corresponding representable functor.
Oh, that was already existing?
That was already, oh yes. There was those Bourbaki Seminaire telling that to define Hilbert scheme or pick a variety, first one was to define the corresponding functor.
So it turned out that Grothendieck's style was just what was needed at that moment in algebraic geometry. Yes. Do you think he sensed that, or was it good fortune that he turned his attention to algebraic geometry?
I think it was good fortune. And I think it was very good also that he had the help in two different ways of Dieudonné and of Serre. With those Dieudonné, I don't think it would have, even with this incredible power of work, and I don't think it would have been possible to have something as beautiful as IHES being written. And I think Serre was crucial to translate for him things which other algebraic geometers had done, because he did not read at all to Italian, but he knew from them through Serre.
Do you have any feeling for what Grothendieck and Dieudonné's manner of working was?
I think Grothendieck would make some relatively rough notes, the kind of organization of the material, and Dieudonné, I don't know the exact method of working of Dieudonné. I think he had many little cards with part of theorems which had to be put together eventually, and then he was writing it up. But Dieudonné was extraordinary for writing things in a beautiful, usable way. A large part of what Bourbaki did was the hand of Dieudonné. So that was really Dieudonné's style, those theorems where there are 17 equivalent properties.
Could you say something about mathematical education at the time? What I have in mind is the old doctor d'etat and the whole way people treated young people in mathematics was so different then than it is now.
Yes, I don't know how it is now, really, but at that time, Grothendieck was really formed me, but not by giving me some project to work on, but by asking me to write those talks for SGA4. And doing that, I get the possibility to do some non-completely trivial thing on the side, which were incorporated there, and of learning some important theory. But finding what one want to do for the thèse d'état, that was the student job. We were not given a problem to work on.
My understanding also was that there was not so much time pressure. No one was saying you have to finish by a certain time.
No, I think it could take 6-7 years, and that was all right. I think this was kind of norm as length, and it was to be some really significant piece of work. So I think Igloos, for instance, it must have been 6-7 years, and it was this complex Grothendieck 2 lecture notes.
So how did you go about finding your first research projects?
It was kind of natural outgrowth of the kind of mathematics I was exposed to. So Grothendieck had those ideas about motive and what Weil conjecture had to imply. So something like property which would follow from what is now called purity. And one concrete things, I think I asked him question what kind of thing one wants to get, and one of the things he told me that if you have a proper and smooth map, the target being itself a projective variety, then the left spectral sequence would degenerate.
I see. So this is a precise statement that he saw as a consequence of
Yes.
his idea of motives.
And he did not put that me as a problem. So there were a lot of concrete things related to motive which one could get through conversation. And so the thesis I got in Brussels was about a solution not involving motive at all, just of this problem. Yes, there was some previous work of Blanchard, but Blanchard was considering the case where the base was simply connected, and then there. But this idea of using the property of cup product and hard-Lefferts theorem were in Blanchard, but for this case of trivial local system appearing. And so I understood that it was still working here, and that one did not have to assume that the basis was projective. It could be anything. And this was at the time not so clear from the point of view of motive. Later it would become clear, but here we are with some mixed thing already, with a base which is... so it's not just the same argument. So that was the first thing I did.
So did you begin to have the vision of mixed Hodge structures at this
That came
time?
somewhat later, but it also was very close to motive. At least as motive was understood at that time. Now the word motive has many different sense, but for Grothendieck the basic puzzlement which had to be explained was that there were many parallel theories for cohomology of algebraic varieties. And when one has the same phenomenon repeating in many different settings, one wants to understand why. And also for the case of H1, it was clear that all cohomology groups were coming from peak zero of the variety. So there we had this model that the real object was peak zero, an abelian variety, out of which one can derive all concrete H1 in L-adic theory, I think also crystalline, Hodge, everything. And motifs were supposed to be the non-existing integral theory, which was explaining that one has all those parallel stories. So even if the formal story Grothendieck was telling was for the pure case, when he was wanting to tell direct factor of some algebraic variety in some sense, the philosophy was not at all related to the pure case. And then it was clear that if one can do something in one cohomology theory, it should be possible to do it motivically, and it should be possible to do it in another theory by applying the realization functor from motif there. And then one had the puzzle that L-adic theory was working as well for projective non-singular variety and for singular or open variety, while Hodge theory was working only for projective non-singular variety. So clearly there was a missing piece in the dictionary. So from the point of view of motif, the question was very clear. Then one had to know...
Did Grothendieck understand this lacuna in the...
I am not sure, no. And then there was something quite different where Grothendieck was important too, that the understanding of that the Hodge filtration is more important than the Hodge bagrading. For instance, for him it was apparent in his definition of algebraic de Rham cohomology as hypercohomology of the de Rham complex. And so there is a spectral sequence, P omega q converging to the hypercohomology, which was giving the Hodge filtration. So Hodge filtration was making sense over any field, while the bagrading was requiring complex numbers. And similar, there was the same primacy of Hodge filtration in Griffith's works, where Griffith showed that one had this transversality theorem, that if one has a family of variety and take a family of cohomology class living in Fp and one take a derivative, one get in Fp minus 1.
I always thought that was later. When did Griffith's transversality come?
69, 70.
Okay. Mm-hmm. So just about at the same time.
Yes, and then there was a third piece of the puzzle, which also was coming from motif, and I think it looks completely trivial now, but I think it's the one thing Grothendieck had not seen, and which then was the key for me, is, so it was clear for Grothendieck that cohomology of any variety, one had some Devisave in two pure pieces, corresponding to pieces of cohomology of projective non-singular variety. It was clear because it was the way everything was proved, by some kind of Devisave in reduction to projective non-singular case. But what had not been obvious for him, I think, or at least he had not told me, was that there was a weight filtration, that those pure pieces were coming in some order, giving a filtration of the cohomology. And this, the way I understood it, was something which looks very naive now, but for projective non-singular variety, H1 is motivically an abelian variety. But now, if you take a singular curve, for instance, H1 in the same way is encapsulated in an extension of an abelian variety by a torus. And in addition, in the theory of abelian algebraic group, there are interesting extensions of abelian variety by theory there are no interesting extension of theory by abelian variety. They would all be taken. There is this Fevale theorem that any algebraic group one has this abelian variety coven, and then the kernel is linear algebraic group.
So this special case for H1, you thought about that consciously as a model at that time?
Yes. And so that was my reason to believe that there was an Hodge filtration. And then, of course, if one believes it, it's easy to check, because one look at various spectral sequences Grothendieck was using to make the V-serve, and indeed, for any variety, for instance, for a non-singular variety compactified by a divisor with normal crossing, one has some obvious spectral sequence to look at, and indeed, it gives a filtration as a Bootman of some spectral sequence where weights are in order.
Right, but guessing that it's independent of the compactification with normal crossings, that seemed to me mysterious.
No, but here it was just to be sure that there were no weight coming in wrong order. That the L-adic cohomology was always filtered with a weight filtration.
Right.
Assuming well conjecture, of course, it was part of the game. Now, if you had two species, one has just to follow one knows. First, one had the definition that one need a filtered vector space with a weight filtration, and that has to be a rational filtration between it exists in all cohomology theories. And then, if one thinks to an Hodge structure as given by a Hodge filtration, that's the thing one tried to have also in the mixed case. And then, of course, one wants a successive quotient to be pure Hodge structure, and that's the definition of a mixed Hodge structure. Really, it was motifs don't appear in the final write-up of definition of mixed Hodge structure and their construction, but were really crucial to get at them.
It may have been just following your nose for you, but I remember at the time talking to many very senior mathematicians who just, your papers seemed very mysterious when they first came out, almost miraculous. I mean, completely miraculous, I would say.
Of course, the time I got completely convinced is when, taking Tits as definition, I could prove one get an abelian category. Then it was in the same ballpark as all other cohomology theories. An abelian category with a tensor product. Then the mirror was good. For me, that was really a crucial point, checking one was getting an abelian category, and it's some strange linear algebra checking, playing with tree filtration in some way. So I remember I was quite upset when one small thread told me, yes, that is just linear algebra. Because for me it was really the crux of the matter.
So the idea of a mixed Hodge structure was like a completely new idea at the time. How did Grothendieck react to this? Did he like the notion?
Yes, I think he was very happy that it was fitting in his philosophy of motives. I don't remember the year it was, but he was starting to get somewhat more removed from mathematics already, I think.
How did you start to work on the Weil conjectures?
Of course, it's something one had always to keep in the back of one's mind, that so many things depend on it. Essentially, for Grothendieck it was purity, and then there was Serre, Kähler analog, which would kind of explain it, and Grothendieck had tried to see what formal property of motive were needed to transform Serre-Kähler argument in an argument which worked in characteristic P. But I must say I had always the feeling that one was completely blocked to use the Grothendieck definition of motif to do anything. One did not know how to construct algebraic circle, and the situation is still the same now. So I did not try at any time to go in that direction.
So his dream was actually to use that definition as part of a proof of the Weil conjectures?
Yes, he had this standard, what he called standard conjecture on motifs, and it did include a positivity conjecture, which was intuitively coming from the Hodge theory, that the motivation of it was. And yes, and he was really fixed in that approach. So I was told that after I had proved the Weil conjecture, somebody told it to him, and then he said, then when I proved the standard conjecture, and then the answer was no, and then he was it was a bad proof, one did not get the understanding he wanted, one would have gotten. Whenever I saw something which could have some bearing to it, I was interested. And then thanks to Serre, I had been interested in modular form. I think one of his courses in Collège de France was on modular form. Then he had suggested that I look at the work of Shimura and Verdier about relation between modular form and cohomology. And so that's from what came this Bourbaki seminar on L-adic representation attached to modular forms. So the idea that something should be possible was an idea of Serre. And tools for doing related things were in Shimura, Igloos, and Verdier.
So you hadn't thought about modular forms before Serre, before your contact with Serre, is that right?
No, it's because it's thanks to Serre that I looked at modular form. Also, I think followed some course by Godman, but it must have been after Serre also. Godman, it was a course about ecoalgebras and such things, so the local aspect. And then also I understood that Raman van Peterson conjecture was a special case of Weil conjecture. And then when I saw that Rankin had proved some better than the trivial estimate for the tau function of Ramanujan, it was something I had to understand what he was doing, because there were no cases that I knew. Before for the Weil conjecture, there were trivial cases when one could compute everything using Gauss sums, or that we had only that motif around. So this was a completely different nature, this kind of estimate of Rankin. So I looked at Rankin paper, which was using some result of Landau, of which the idea was that if you had global information on some L function, you could get from it some information on local factors, with a number of assumptions, like it had to be with positive coefficients, so it was for Rankin he was using tau n square, and using his theory for that Dirichlet series. And then I understood that in algebraic geometry one had some understanding of L function thanks to Grothendieck, because one had this expression in terms of cohomology, so we had something one could play with. Of course, one needed to understand where the poles were of the L function one needed to consider, but at least that was the initial input, that to understand a given object, it was good to put it in a family and to have some understanding of a corresponding global L function, and then one could try to go back to the local factors. And in the case of Rankin, it was quite delicate using explicit information on the gamma factor which one has. In the algebraic geometry case, it was much more trivial, the kind of information one need, but it was the same idea, from global to local. And the first case I could manage was an hypersurface of odd dimension in projective space, because that was a very clean case. There was kind of trivial cohomology except in the middle dimension, and in the middle dimension something with a big monodromy, which I knew something about thanks to Pierre Lefebvre, and I had understood work of Lefebvre on monodromy, so I had enough information to compute some the monodromy.
So by could manage, you mean you could prove the whole thing for
I
those?
think quite directly I could prove the correct result for such an hypersurface of odd dimension in projective space. And then I wrote that to Serre, and Serre told me later that this was essentially the day he broke his tendon d'Achille, how do you?
Achilles tendon.
Achilles tendon. And so he received this letter, and then he was euphoric going in the hospital to have his tendon repaired, because for him it was clear that if one could do that, then one could hope to do more. So indeed, one needs to put things together, but that was a crucial argument. Because I had done a few things before which had prepared me. Some were not useful, like that Weil conjecture is true for K3 surfaces, but this was by reduction to abelian variety, and there were other cases which could be reduced. So there it was more playing on the motive and understanding that in some sense what could reduce motif of various objects to motif of abelian varieties. Not in the framework of Grothendieck motif, but still well enough. In the framework of what later would be absolute Hodge circle, essentially. Then I was prepared also by having read Lefebvre's book, Analysis Situs and Algebraic Geometry. And I think this was because of a question of Grothendieck. There was this question to prove the Hard-Lefebvre's theorem, and Grothendieck was told that it was proved in Lefebvre's by topological kind of argument, so he asked me to look at it. And I answered to him that from my point of view the proof of Lefebvre's was nonsense, but still I had the book, and there are many interesting things in the book, which then were translated in algebraic geometry in this seminar on vanishing circle and monodromy. And this was an input in the first proof, at least, of the Weil conjecture, understanding monodromy in non-trivial cases. So that's how it came about, not following Grothendieck ideology that one should first understand the standard conjecture and derive the Weil conjecture from it, but being inspired by what people of automorphic form were doing. I am always very attuned where things don't fit, and one thing which was not fitting here is that L-adic cohomology give eigenvalues of Frobenius which were L-adic numbers, and here one was wanting a property of them which views them as complex number. And that's something I thought first to understand. No one thought that those eigenvalues of Frobenius are independent of L using the Weil conjecture, but first I thought to give a direct proof in the projective non-singular case of independence of L of the eigenvalues. And this was involving playing with monodromy. So all of those things has prepared me.
Grothendieck had already left the IHES at the time that you finished this proof?
Yes. He was already recluse, I think, in Vilquin at that time.
Did you become a professor there before he left or after?
Before he left. And so it was agreed I would be a professor, but Motfan told me that I should still have some experience of the world and spend at least a semester in Harvard, for instance.
And did you?
And I did, yes. And then when I came back to Brussels, and I got a phone call that I was to come back immediately because there was a fight between the professor and Motfan about, essentially because Grothendieck was extremely unhappy that IHES was getting funding from the Minister of Defense.
I see. So Grothendieck would have liked you and Tom to take his side in this fight?
Yes, and he was also hoping to force the hand of Motfan that I would refuse to be professor if there was this military funding. But I didn't. I was mathematically, I was very close to Grothendieck, but not about relative importance of mathematics and something else, at least what he was thinking at that time. So I felt that survival of IHES was more important than military funding. And so I told Motfan that whatever Grothendieck did, I would stay. And of course, from the Grothendieck point of view, I was a traitor doing that.
Over what period of time did he become interested in politics?
I think 1968 was a big shock for him. Then,
was he involved in the events of 1968?
I think that's about the time that he spoke with a lot of people, but the shock for him was that he was considered as, I don't know the name in English, mandarin in French. And he was not at all viewing like that. He was not viewing himself as being part of the establishment, even if he clearly was. I don't know, then he spoke with a number of people and got interested in ecological questions. That's the beginning of the Survivre group, later called Survivre et Vivre. I think that's one reason for him getting away of mathematics, feeling that survival of the world was more important than mathematics. I think another shock he had, but is that outside of mathematics, people did not find that a proof was sufficient to change one's behavior.
Right.
I think the Mephian's antagonism to military was old, but had no reason to be on the surface. And it's not directly related, but still he was in some French concentration camp as a child, so he has very strong feeling against any kind of authority.
This was during the war?
Yes, so I think his mother was in Spain, and then when she fled Spain near the beginning of the war, all those fugitives from Spain were in some camps.
Okay.
And afterward, he was saved and got, but still, any authority was suspicious to him, and in particular anything to do with military. And possibly he was somewhat influenced by Godman on those matters too.
What was your working relationship like with Serre?
Serre was not at all as close to me as Grothendieck. His lecture in Collège de France were always beautiful. One had the feeling to understand, and if one made the effort, one really understood a lot following his lectures. And then he made me learn. First, I learned things by his lectures, and also he found it would be a good idea for me to give some Bourbaki seminar, and doing so, I have learned a lot also.
It was his idea that you should give the Travaux de Shimura seminar?
Yes. When I could do it, he had told me that it would be good to look at Verdi and Shimura and Eckler-Shimura for automorphic form related to L-adic representation, and the corresponding Bourbaki seminar afterward. Yes, I think this one I had the result, and Cartier was supposed to speak of something else but fell ill, and then I gave that seminar.
I see.
Shimura was harder, and there also, so it was his idea that Shimura was interesting and I should look at what he's doing and explain it in an understandable way. And to reach an understanding motive were crucial also, because Shimura's point of view was to view all the algebraic group involved in terms of algebra with involution. Motive was suggesting one should look at moduli space of motive or moduli space of Hodge structure. And then if one believes in that point of view, everything had to be expressible in that language. So Vernon Shimura had this rule of how Galois, now he was telling it differently, but now one would say how the Galois group should transform the connected components of the Shimura variety or act on CM pound. And so if one believed in motive, it has to be expressible in that language. And then this was essentially forcing the definition which is not now used as what Shimura variety and the corresponding reciprocity law. While in Shimura it was kind of case-by-case story for the various kind of simple algebras with involution.
So there are a number of cases where you have read somebody's work and then digested it and made your own version of it, which, for example, in this case, I think it's what everybody reads. I mean, it's the most, I mean, it had an enormous influence on the development of this field. Do you find this is a useful way to get started on something?
Yes, when I want to understand something, I first want to have some panorama of understanding when things fit. I am not interested first in proving a particular problem. I want to understand what is related to what, possibly what one has to prove what else, but in the imitation of Grothendieck, that the first thing is to understand what are the correct definitions. It does not follow afterwards always, but it helps at least, even if it's not enough to make proofs. I think it might also be related to the fact that I am quite bad at making computations. So it's not something I can rely on, so I have to rely on something else. Also, being bad with computation is also related to the fact that I am very reluctant to break any symmetry in a problem. I will go to great efforts, like for instance, not to use a coordinate system if I am doing differential geometry but expressing things in invariant terms. Because if I don't, I will make mistake. I cannot compute well enough. So this is also a reason for me to avoid computation, because usually to make a computation one starts by breaking the symmetry.
So in addition to your Bourbaki seminars and the parts of the Grothendieck seminars you participated in, you've given a number of lectures over the years and also written private notes for yourself, almost always in the style that you're describing, where you lay the foundations very carefully and then everything is very, very beautiful. The people have found these very useful, but in general, to get them, you need to know somebody who has a second Xerox.
Yes. I find that writing letters is very useful. Essentially, when I write a letter to a mathematician, first of all, I write it to myself. Then it can be used also. And it's also very useful to make a complete proof, and there are things one see only when making a complete proof, which then can be reused elsewhere. But this takes a lot of work. So writing a letter and to be able to clarify one's mind, I find it extremely useful, at least for myself.
I know a number of these letters have become papers by the person that you wrote them to. Do you find that a useful process?
That's very good. I am very happy. It means I don't have to write it myself, and usually the people doing that add some new ideas to it also, so it's better. Yes, maybe I should tell that I am always unhappy when I see competition in mathematics. And of course I was in very privileged situation. I got, at the time when I was starting, jobs were plentiful, so people in general did not have to worry as much about finding job. And myself, I had a paradisiac job almost at the beginning too. So I was not to be worried. But then I think it's also the influence of Grothendieck. There were all those people around him, to a large extent developing his ideas, so trying to, and trying to develop it in a way which was usable by other people also. That was a crucial aspect for Grothendieck. The reason to do things in of generality and not strictly limited to one thing one wanted to prove was that then it could be used for something else also. So for me that was the natural way of of doing things, that one was collaborating to advance enterprise, and it did not matter much who had proven what, especially for me at the beginning, because clearly the main thing was what Grothendieck had done, not what I had done. And it somewhat pains me when I see competition instead of rejoicing about what other people are doing.
Did you feel that there was competition in Paris at the time outside of Grothendieck seminar? Or
I was not much outside of Grothendieck seminar, and I was mainly speaking about mathematics with people. So I'm sure there was, like, I had some echo from previous time about how there was some fight in Sorbonne of who would get this position, with Bourbaki on one side and people like Loret on another side. But it was just some anecdote for me, of which I was not paying much attention.
how did you first end up going to Moscow?
I don't know what the idea of inviting me. Maybe Grothendieck had mentioned to some Russian that it would, or Serre, that it would be worth inviting me, so they took the occasion of some anniversary of Vinogradov. Things were completely new to me. I had no idea of what the situation was, no idea of the anti-Semitism which was taking place. So I spoke with a number of people, in particular with Tits Shapiro, and so we have a long discussion, and then I was telling, yes, but now I have to go to this banquet for Vinogradov. I expect you are coming too. And he was not.
No way. What year was that?
I think it's 71.
I see.
I should check, but I think.
Okay, so approximately.
And then it was very nice to speak with people on the kitchen table. Yes, and people were. And I don't know if it is that time already. I attend Gelfand seminar or Manin seminar, but it was an atmosphere which I liked very much. Still feeling and feeling more on subsequent visit all the difficulties there were in impossibility to come abroad or with great difficulty. That when I had to give a talk in the university, one has to smuggle me in through the club entrance, and Serjova Gelfand being with me with his card and pushing me to go. And the same in Steklov Institute, which was a little more difficult.
Right. So did you go back regularly then during the 1970s, or?
I went a number of times. Yes, I think around 75, and then eventually I married Lena in Moscow, and then we continued to go afterward regularly too. But it was first for mathematics before I met Lena.
So you go at least every year now. Do you still talk to mathematicians when you're there?
Yes, but I feel that it's not. There are not as many people as there were at that time. People are still enthusiastic, the people I meet, but it's not like I was there at Kafdan and there were Kafdan, Bernstein, Bellinson, and we all speaking of what would become perverse thieves or things like that. At that time it was, I feel, the way to do something which was not controlled by the Communist Party, which was worthwhile doing. And now many of those people are here in the West or in Israel, and one feels the gap.
I was struck, I remember at the Gelfand Memorial, somebody made the comment that in some sense it was magic because of the repression, because people like Gelfand and Mannen and Beilenson could not travel abroad, they were always there. I find it hard to process that.
It's true, I am afraid. Of course, there is also the fact that the material situation for scientists were a little better, I think, than now. Now it's starting to get a little better, but with a lot of constraints. But it was possible to live, even sometime in fear, while afterwards people really had to, when it was possible to go abroad, people had to do it, even if there was not their wish, but to have enough money for living. Right. And for a system for which those seminars were crucial, if the thought of the seminar is abroad after the time, it does not work so well. Plus, at that time, Mechmat was a beautiful place, even if it was not perfect, but now the level has gone down. There are other places which are good, but not with the same contact with students, for instance. I'm amazed how the basic educational system is good and continue to have very good people coming out of it, but now leaving earlier and earlier.
Are you concerned with the continuity, with the strain of people leaving so much?
I think that 10 years ago I would have said that this cannot go on more than 5-10 years. It has gone on, and I would say the same, and each year I put the boundary a little further away, but when people go abroad here to get their PhD, because then it's easier to get immigration paper, this is terrible for the mathematical schools there. And also the number of places where there are people is smaller, but there are essentially now only Moscow, Leningrad, and St. Petersburg, and Novosibirsk. Mm-hmm. And before, I think it was, those were the main places already, but it was not so big contrast between the center and the periphery.
A lot of amazing things coming from Kharkov, for example.
Yes. And Rindfeld was in Ufa for a while.
Didn't know that.
Mm-hmm.
What made you decide to leave the IHES and come to Princeton?
I think there were a number of things. In a way, it was just going from one paradise to another. Then one was a feeling that it was not a good idea to spend all one's life in one place, that it was better to be. Then another is that I was feeling that I was getting into some pattern and falling into the newspaper much too much. I still do it now, so it did not help to move. And then also I had imposed myself to give one seminar every year, and this was getting a little too much.
Of course, the audience of those seminars in Paris found them extremely useful.
Yeah, I think this kind of seminar which was there was extraordinary. It was one or a few people, one subject, something new. And it was a beautiful medium. I was never able really to be like Grothendieck and have people writing things up for me. That was not the way I was working. But to be able to explain things and to have the reaction of people, that was very good. But getting older, it was getting somewhat too much for me to do.
Yes, I can't imagine you're making assignments to people and insisting that they do them.
No, that I cannot do. Impossible. In the same way, very few people were formally my student, because the idea of telling people what to do and feeling responsible if they can do it or not do it, that's something I cannot handle. I'm always very happy if people ask me questions, and usually I can just answer by another question. Sometimes I can tell something, and that I like very much. But having charge of some other soul, that's too much for me.
Yes, I noticed that one thing that happens often is you will be reading the newspaper in the common room, and then some young person will come up who was...
Then I am very happy. I have something more interesting to do.
Who was otherwise afraid to talk to you, but under those circumstances they were willing. And
so maybe it's good to something.
Yes, I mean, of course there are many young people whose theses depended essentially on a series or some conversations they had with you. You also would never tell anyone, that's a stupid question, don't bother me.
I would not dare, no. And that's also the result of my experience. I was so well treated when I was young that I think it's all right to be acerbic or brutal against older people, but young people are sacred.
You probably don't know this, but some algebraic geometers have thought that, you know, various young people were wasting your time by spending so many hours talking to you. I take it you don't have this feeling yourself. I mean,
also nice to feel a little what the people know and then use a language which they can understand. It depends on very little. One should usually the people here are bright, so one has not to use frightening words, but explain what things are about. So, and if it is to explain something elementary, there is nothing wrong with that either.
when you write a paper, it's usually in the things are done in their natural generality. It's categorical. The definitions are done in the most beautiful way. But when you discuss mathematics, it's very often discussing the simple examples. Mm-hmm. Could you comment on the tension between the very specific examples and the general theories?
My first idea that something is true is to look at a number of examples as simple as possible, and usually when you make some pictures, they are relatively elaborate and beautiful. For myself, if I can use the zero sphere instead of the one sphere, I prefer. then I have always in mind a number of things which can go bad in this situation or that one. If it is some question about topos, I know what is bad about FPPF topology. So I have a number of examples and counter-examples, and often if something looks plausible and if it passes a battery of examples, and in first approximation I believe it's true and I go on. Then of course one has to understand exactly why it's true and make the proof, but that's somewhat why it is more painful to write a paper than to understand what is happening.
Did Grothendieck check things with examples?
I don't think so, no. Checking, no. Of course, he had a very big interest in a relatively simple object, like, for instance, a fascination for curves, which in later work, which he, like this program about understanding Galois group of Q bar over Q, many things are related to curves. And also the basic result about étale cohomology were depending on the understanding curves. And he also, earlier he gave some talk at some seminar in the 50s about one aspect of Teichmüller theory, but understanding what it means that the moduli space of curves, what it means, and that it is of dimension 3g minus 3 and so on. So some simple objects were important in his proofs. He was trying to reduce complicated objects using nice functoriality to elementary cases, but checking on complicated examples, surely not. There is the famous story about L-adic cohomology, somebody asking, can you make it a little more specific using a particular prime? And maybe take the prime 57.
Yes, I've heard this story many times. Is it really true?
I don't know. But it would be his reaction that nothing is gained by taking a particular prime, so one has not to ask this question.
Right, it's psychologically true, even if it's right. So in mathematics, it seems to me that there's a tension between the great dreams, which are often unrigorous, and the rigor of what we actually write. So for example, motives is a great dream, or the Langlands program, or perhaps the idea that things should have a mirror image. The dreams where different from conjectures like the Riemann hypothesis or the Bayes conjectures where there's a precise statement. You've actually dealt quite a bit in areas that touch on these great dreams. Do you find there's a tension between them and the rigor of mathematics?
No, I find it's a guide that it is because of those dreams that one can see how things fit together and know what is worth trying to prove, and so that's an organization principle for me to have those dreams. And then of course one has to find place when one can tell something concrete using the philosophy. And to a large extent what I have done was often to have the philosophy in mind, which was asking things which seemed inaccessible and finding way to find substitute of some idea to have some really concrete statements. There is the story of absolute Hodge circle, which is sometimes a substitute for the Hodge conjecture, even if imperfect.
Do you think the Hodge conjecture will be true in the end?
No idea. I think we have no evidence, and the logical status for me is very strange in that, for instance, if you have a family of algebraic variety, we have no way of deciding whether somewhere in this family some Hodge circle occurs. So this makes it quite difficult to have any candidate counterexample of a general nature for only per surface, because we don't know where are in a concrete way the circle predicted by the Hodge conjecture. And then there's a circle for which there is a good reason for the circle to be of type TPP, like the Cunet component of the diagonal, or applying the inverse map of the Hadley-Fetz theorem. But there, what I have tried, but with limited success, is to see what those cases can have in common and how to find some substitute for the Hodge conjecture which would be good enough to handle those circles. And then for a number of them, like the Cunet component of the diagonal, you have circles, but if you reduce them over a finite field, they will become algebraic. Now, it's not enough. I hope that there are more things one should be able to do. I never succeeded, but I hope that for abelian varieties, for instance, one could do, for the time being, one has a good theory with absolute Hodge circle in characteristic 0, but in characteristic P, as one does not have the crutch of the integral cohomology, one gets lost. But still I have the hope that this is one way one can go around it for the things we really care about.
Many mathematicians actually feel that the world would be a terrible place if the Hodge conjecture were false, but you feel that there could be a substitute which would...
Yes, I believe in many consequences of the Hodge conjecture. There are things which I would be really distraught if things were false, like for instance, if I have an abelian variety over C and two Hodge circles, then I specialize to characteristic P, or rather I should take Frobenius and one of those circles, and I take an intersection number. I want it to be a rational number. But I think, in the same way, I feel that K-theory and Voevodsky approach to motive, or also Grothendieck, are reasonable only if something like the Hodge conjecture is true, if K-theory groups are reasonable. And as we have no evidence for that, my tendency is to try to find substitutes.
Could you say something about how you approach mathematics? Suppose you're entering a new field. What do you do?
First, I want to get a general picture and understanding how things fit together. And the way I can be interested in doing things for one question is how the haphazard. I continue to follow an advice Tits gave me very long time ago, that I should do what I like. And I think that was an excellent advice. And I can be as much attracted by very special looking questions as by big theories. When I am still fascinated by configuration of hyperplanes, and I still would like very much to know for which linear configuration of hyperplane all the complement is cut by those hyperplane into simplices. We still don't have no idea. We have a large number of examples, no general theory at all. And if somebody tells me beautiful things about Grassmannian, which seems to be true, then I will try to understand what is going on. But first I need trivial example and a general picture of how things fit together. And it's picture. I don't work much. I don't think in an algebraic way in terms of formula. My pictures are kind of picture, not detailed picture at all. But that's maybe related to that I am so bad with computer. Not much better in drawing, but at least in one mind one can make better drawing.
How would you imagine the future of motives?
To it be really powerful, one needs something completely new about algebraic circles, or K-theory group, and there are many equivalent versions of it. But even if it, in its present state, I think it's extremely helpful. It would be very difficult, for instance, to formulate Langland's program without this notion of motif. And so I think as a basis for intuition in algebraic geometry is crucial, and it will remain crucial. This principle that all cohomology theories tell the same story, or should do so. Often if I have a question in one cohomology theory, I first think to another one when things are a little easier, and then I go back. For instance, I can more think of things I have done, but when I start Hodge filtration and action of Frobenius are somewhat parallel thing. Now, any natural morphism is compatible with Frobenius by transport of structure. So one knows that the same has to be true for the Hodge filtration, but there it can be difficult to prove. But at least the philosophy of motif tells us it has to be true. I think this will remain extremely precious, that if one wants to tell things about integrals of algebraic quantities, one should at the same time keep in mind L-adic cohomology. If one takes to Fourier transform in things related to analysis, one should also think in mind the same in algebraic geometry. So for me it's a unifying principle which sometimes one can directly translate the argument into proof, but that's not the main use of the theory of motifs so far.
I think it would be interesting to talk a little bit about some of your non-mathematical pastimes, which are really quite unique even among mathematicians, who usually have quite individualized taste of what they like to do. So for example, it seems to me almost every winter you build at least one igloo and sleep in it.
Oh yes, I like very much nature in general, and that's one part of it. But every year I try to have 1 or 2 weeks of walking in some national park or on trails or bicycling for a few 100 miles.
Right. So this will be a continuous walk of a long distance.
Right? Yes, I dislike cars very much, so if it takes 1 day to go somewhere, one needs at least to spend a week to enjoy it and recover.
So when did you first build an igloo?
Must have been in Princeton, because there is not so much snow in Bure, but... no, that's not completely true. I think when I was 5 years old, there was a big snow in Belgium at the seaside, where my parents had a small house, and my brother and sister decided to make an igloo, and I was used to dump the snow, so they were taking me by my legs and my arms and using me to compact the snow, so it was very useful.
Wait, the snow was in a container, or?
No, it was on the ground, but one has to kind of make bricks with it.
Compactify it.
Yes, and cut it with a shovel, perhaps, yes. So that was my first experience with an igloo.
It was your brother's idea?
Brother and sister idea.
I see. So this is a family thing. I didn't know that. I see. Do they still make igloos now?
I don't think so, no. But in Belgium it's
yes, of course.
difficult.
Would they, if they had a snow? I mean,
that's quite possible, yes.
All right.
And then the Boy Scout made me some contact with nature too, which I appreciate. So in the winter now I still like to start the day by building a fire in the chimney.
Which you collect your own wood?
Yes, of course. But it's easy. I'm living at the corner of the woods, so one has just to walk 50 meters and collect. And I find gardening to be very relaxing also. I'm very bad at it because gardening requires to be systematic, to take the weeds in time, and that I cannot do. When I do mathematics, I completely neglect the garden, and then my son was telling me it's like an elephant could hide into those weeds.
But nevertheless, vegetables come out of it.
Yes, yes. If the rabbit has not eaten everything.
One year in France, there was a very fastidious gardener whose little plot was just perfect, and it seemed so out of place.
It's like in later also that I like the French Republican calendar, especially in France. In this calendar there is usually a plant or an animal, sometimes a mineral or a tool attached to each day. And really it's worth looking what the saint of the day is and looking outside to see why it has been chosen for that day.
The saint in the sense of the Republican calendar.
Yes.
So was that the point of the Republican calendar?
That was not the point, no. That was the idea of Fabre d'Églantine, who attached those. In this way, it was anti-religious to have something else and to say.
Until then, every day had a saint, and you had a name day and all.
Yes.
Mm-hmm. But your fascination with calendars goes beyond the nature. I mean, you celebrate, for example, St. Nicholas Day and.
No, that's a children festival in Belgium. It's very important to have St. Nicholas giving toys and cookies or orange to the children which have been good during the year.
So that was part of your family tradition?
Yes.
I see. And the Poisson d'Avril, was that also part of your...
The idea of to make cookies in form of fish, no, that's, we once in Chinatown found something to make them.
So that's your original?
Yes.
Yes.
I found that the French Republican calendar is a beautiful, flawed idea. One of the aim of a calendar is that the seasons come always at the same time in the calendar. And then the idea was that to take this as definition of when is the first day of the year. Of course, the people doing it had not at first understood that it would make a mess, that it would be sometimes difficult to tell if the equinox fall a little before midnight or a little after midnight. And also it make it impossible to predict how many days will be in a given year a long time in advance. So they were flawed, but the ideal, I find it's very nice. Like, for us it's very useful to permute definition and theorem, and it's an instance of that for calendars.
I often try to get people to visit at the time of the flowers blooming in Princeton, since it's so beautiful, but it changes.
Yes, France is much more forgiving, so the calendar is better adapted to France. Here the spring is so short, going from winter to summer. In France, I think it's much more reliable, and spring is really 3 months and not 1 month and a half. But what I find beautiful here is the space. In France, things are always crammed, that one has those poor trees on the side of the road, which are completely cut,
Yes.
and a little garden in front of the houses. So when one sees here at the Institute this beautiful linden tree, which has all the space it needs, it's really a pleasure.